Hello, hello everyone. How is it going? Sorry. How is it going? How's it going? Thank you for joining. Hey Jessica, and how's it going? How's it going? How's it going with you today? Kind of lower the volume, the audio, the music a little bit. I hope that's okay. And how's everybody's Monday going? How is everybody's Monday going? We're gonna quickly start off. Before that, uh, uh, before that, sorry for that. Sorry for that. Sorry for that. In which language do you code? So the primary code that I do is in Java, and today we are going to do Java. That's the primary thing that I work on. But other than that, I have working knowledge of. I have worked on Python. I have worked with Go. I have worked with JavaScript, specifically because I work with React on the front end. But yeah, I have also worked on Node.js. One of my recent projects that I've worked on is on Node.js, and hmm, it was just a toy project that I worked on. I was attempting to also learn C. I have got a bit far, but I haven't done anything serious with C yet. Yeah, that's pretty much it. That's pretty much it. Those are the languages that I do. But again, Java, I would say, is my bread and butter. And currently, I'm working on .NET, which is a very shit language in my opinion, by the way. I'm sorry to hurt anybody or, you may think otherwise, but we are entitled to our opinions, right? It's a little bit shit, I feel. Not the language itself, the infrastructure around it itself. But yeah, okay, cool. We have our ChatGPT open for notes and for any kind of help that I need. We have AlgoExpert open, and Remove Island is something that I've done before, but I'm pretty sure I haven't actually done it in my listing. So let's get started. I hope the font is okay. I forgot to increase the font a little bit before starting the stream, but I hope that's fine. Mm, and I'm sorry, in between, I would be switching the tab to look at your chat. I don't use a second monitor because I don't like it. It's very distracting for me, but I might get because of the stream purpose. And I was trying to work with my phone, but that is also annoying keeping to look at something. So yeah, I'm really sorry if it's a little bit delay in answering the questions. So sorry. Cool. Need some advice? Yeah, please go ahead. Ask out. I'll try to give the best advice possible. I just completed my internship, but did took the offer to take the FT offer, full time offer, and now searching for a new role. Any tips you can give? Mm, I just completed my internship but did take the full time offer and now searching for a new role. Any tips you can give? So, first thing I would say is right now with the market, with AI hype and all of that, yes, I'm calling it a hype right now because not people, everybody is using AI in the correct way and the essential way that it's supposed to be used. So, the market is a little bit unstable, and you can see that if you can actually read markets, the money market, those things also give away a little bit of how unstable the job system is right now. Okay, but I feel that you can still try and get a job if you can utilize the best possible. Except I'm seeing just a second. Okay. So yeah, my bad. Sorry. Okay. So what you can do is you can basically start expertising in one of the things. And what I believe is one of the things which, so there are two parts which I feel is there to a job. One of them is on actual knowledge to computer science. One of them is actual knowledge. The second part is marketing and selling yourself. Okay. To sell yourself, you have to showcase skills a little bit extra than you actually have got. But remember one thing, if your basics are good, if your fundamentals are good, you can sell yourself to know anything and everything. Okay. What people usually look for, what I usually look for when I take an interview is that I see that if you will be able to scale up, I see that if you will be able to work with me, and I see if I'm comfortable, working with you or like mentoring you or getting mentored by you if you're senior, depending on who's. I have taken a couple of seniors interview, but yeah. So that's the thing. Um, Concentrate on one thing and be the expert, but then the fundamentals has to be very clear. The fundamental has to be so strong that you can switch languages so easily. Stuff in a little bit of Gen AI in there. Again, when people talk about Gen AI, they're looking at stuff like, can you use Claude? It's a tool. I don't know what's there to learn to use. But I suppose what you can showcase is, so as an example, let's say I'm taking an interview for you and you asked me the previous question, what language do you code? And I'm taking an interview for you in JavaScript and you have never coded in JavaScript. You have worked with Java. You come to the interview and I say, hey, the role is for JavaScript. So do you know the basics of variables and things like that? Yes, you can. You can write code. You would have studied a little bit of JavaScript. It's Java, JavaScript, React, Spring Boot. Yeah, so you can actually apply for a couple of full stack jobs. So my point is that be strong in Java and JavaScript because Spring Boot Reactor frameworks or libraries which can be replaced, which you can build, and which you can showcase that hey, um, I can work with any framework tomorrow. It's not a big deal. But let's say that you're more strong with Java and you're a little bit less strong with React. But when you start coding, I can basically ask you that hey, um, can you use Gen AI to work out this feature? And if you showcase me that how you prompt, or if I give you an existing code base and you can showcase me that you can use good prompts to figure out how things are and then copy paste, because mostly you will not be working on greenfield projects or which are like new projects, you would be working on an existing code base. So you should know the power of something called grep. Grep is a command line utility for searching plain text data. Okay. So uh, let's say I'm in a project called image upload. Okay. So I am tomorrow asked to work on this project and someone tells me, hey, there is a logo which needs to be fixed. So the first thing I would probably do is logo. And look at that. It spit up a lot of things, but it spit up a lot of things. And okay, it's a very simple, vague search that I showed, but how I'm trying to showcase is that your grep or filter, depending if you're using Windows, maybe some kind of search option you would use on the GUI. I usually prefer the terminal. There is grep, there is rip grep. How quickly can you navigate through the code base and learn it? If you can showcase that, I feel you are pretty much in a good place. Okay. Plus, you're working a good stack, which is Java, JavaScript, React, Spring Boot. Increase your knowledge about microservices and do not just read something. Do a project. In my channel, I'm gonna be doing a lot of stuff which might not make sense. So as an example, I might be doing a very small project which might not make sense using a framework, but I'm gonna use it because I want to learn that framework. Okay. This channel will be more about learning and sharing and documenting my journey. So 5 years down the line, I can see if I have evolved or not. Or 1 year down the line, I want to see if my code quality has improved or not. Okay. So similarly for you also, if you want to learn something, just go ahead and do it. Do not think that, okay, is this a big, like people might say, oh, for this project, this is a big library. So fuck it. Simple as that. You wanted to learn Spring Boot. You wanted to learn Micronaut. You learned Micronaut. You wanted to learn Kafka. You introduced in your own project in a place where it was absolutely not required. Because like 2 people, 5 people, 10 people, 100 people is going to use it. It's not going to scale to a million. But why care? You wanted to learn. Just don't go through course. Get some hands dirty. And I feel that's going to be more helpful. Because when you answer questions to an interviewer, anybody with experience can easily counter question you if you give Things like, oh, I worked on microservice. This is a Hystrix server. This is an Eureka server, right? I can easily counter question you, and I can feel that if you actually explore the library yourself, if you actually explore the framework yourself, or you have tried to build something yourself, okay, that is what my, I cannot say 2 cents now because I told a lot. That is what I feel is gonna help you, uh, build your career. And you have AI now. I use AI to learn a lot of things, but you have to have the ability to know that if it is spitting out or whatever it's saying is correct or not. You should be having the capability to verify that. So use those capabilities and build on that. Okay. And to be honest, I feel Java, JavaScript, React, Spring Boot is a pretty good stack to apply for any kind of a full stack project, right? Yeah, go for it. And nowadays, people are always about DSA and all that. So I might create another video on what my opinion is, but in a single line, what I want to say is that lead code style interview may suck, but it is what it is. And if you're learning DSA only for interview purpose, if you're learning anything for interview purpose, I feel it's not correct. For me, learning is more important than exploring is, but maybe not for everyone. So since just go about and see how they have been interviewing for the past 1 year. If they're doing DSA and system design, LLDL stuff like that, just go ahead and do it. That's all. That is what I would say. Yeah, I hope that was helpful. I hope that was helpful. Yeah, cool. Let me start back. Okay. Okay. So yeah, coming back to the problem. We are gonna work on remove islands today because, as far as I remember, we didn't do remove islands. Let me see. Yes, we did youngest common ancestor, and this is youngest common ancestor. So remove island is what we're gonna work today. Cool. Damn it, I already solved it here, so I'm just gonna say okay, bye. So you're given a two-dimensional matrix of potentially unequal height and width containing only zeros and ones. The matrix represents a two-toned image. Two-toned image. So it has two tones, or it has two colors, where one represents black, okay, and zero represents white. An island is defined as any number of ones that is horizontally or vertically, okay. So, and you do not touch the wait, horizontally or vertically adjacent, but not diagonally, and that do not touch the border of the image. In other words, a group of horizontally vertically adjacent ones isn't an island if any one of those ones are in the, okay, so it cannot be on the outer bounds of it. So even if it's an outer bounds, we do not consider that to be an island. And whoever is attached to that. An island can twist, of course, okay, blah blah blah. You can think of island as patches of black that don't touch the border of the two-tone. Write a function that returns a modified version of the input matrix where all the islands are removed. You remove an island by replacing it with zeros. Sorry, naturally you are allowed to mutate the input matrix, of course. Thank you. Hey, no problem. Welcome, man. I hope it's actually helpful, and all the best with your search and all the best with your career. Sure, it's gonna rock. Okay. Write a function that returns a modified version of the input matrix where all the islands are removed. You remove an island by replacing it with zeros. Okay. Time for whiteboard. Yeah. Good. Okay. So basically, this cannot be an island because it's on the border. Now, this will be an island, so let's mark it like this. So this will be an island. Let's not mark it like this. This will be an island. This here will not be an island because of the fact it has one of them in the borders. So yeah, it extends till here. Okay, cool. This right here is this right here is a island. This right here cannot be an island. This right here is an island. And none of these can be islands. Okay, cool. Wait, we need white. Yeah, so this cannot be an island even though it's 1 1, but it's on the border right here. Well, technically speaking, it's all of these stuff together. Or a landmass, but it cannot be an island. Here, it cannot be an. Okay, so the ask here is that whatever things you have in pink has to be converted to 0. Okay, food has to be converted to 0. So where is my answer? Okay, is this same? I wonder if, yeah, this is same. Okay, so yeah, this thing is 1, and yeah, this thing is 000. So this one got converted to 0, but this thing remains 111. Then you have 4 zeros, 1 0. This thing converted to 0. Okay, so I think we are good here. We're wrong. We are good. Okay, cool. So how do we approach this problem? How do we approach this problem? So last time we did a problem similar to this, which is I think reverse sizes. Yeah, so we did a BFS. Well, we did a BFS flood fill to count connected ones. We are gonna take a similar path, but the problem here is that we cannot take into consideration these things. So when we do iterate, we have to keep a check. We do have to keep a check that if any one of the connected cells are in this thing, but we have to still mark them, because from here, if we start, let's say from here, if we start, we go here and we say, oh, it cannot be. But if I break out the next time I come here, or if there was a 1 here, it's connected to the above one, that would say that, okay, it's still something that I can mark. Okay, so we have to be careful about that. So we have to iterate and mark everything, and then we can keep a simple flag that says that if I need to fill it up. The problem here is once I do iterate and I mark everything, I kind of also need to store what I visited, because if I do need to mark, I need to have that information. All right, I need to have that information. So that is also a little bit extra space, which I am not quite happy with. Maybe we can do something else. So that is one of the approaches that we can go with, right? So in here, okay. So one thing is, again, last time also we didn't mutate the array. So what we did was we mutated the input and then we mutated it back again to the original state. I'm thinking to do something similar here. What we can do is, what we can do here is that, sorry, what we can do here is a very simple thing. We can say that, we can say that, okay, so you have, so you have, it's too much light on my face. Increase it a little bit. I hope my stream doesn't go bad. I hope I don't look bad on the camera. I mean, I generally look bad, but it shouldn't look bad on the camera. That is what is more important, right? Yeah. Okay. So what I can do here is that, so we always have 0 and 1. Why don't I change this pixels, not pixels, and yeah, technically we can call it pixels because it's called an image. So whatever. So we can change these things into 2. So what I do is I go over the first row, the last row, the first column, and the last column. I go over that, and then I simply, and then I simply, uh, then I simply take this element if it's 1, and then I mark everything as 2. So now the array would become 2, 2, and because I'm doing a BFS, I would be doing it in this way. 2 here, 2, 2, 2, 2, 2. Then I'm going to iterate over the entire array, and I say if it's not 2, make it 0. Okay. So now these would be converted to 0 by default, and then I'm going to iterate one more time, and I'm going to say, okay, if anything is 2, convert it to 1. That sounds like a pretty good approach to me. That sounds like a pretty good approach. Right. The only question here is how do I iterate? Because I can of course have four different loops. I can say iterate over the first one, iterate over the second one, iterate over the third one, iterate over the last this one, right? But the problem here is that for every one of them, I have to do a DFS, and I don't want to write that code repeatedly. So I can extract it out to a function. But if I extract it out to a function, how do I pass the variables of where I'm iterating over? I think I don't need to do that. I just need a starting point, and from there, I'm gonna have to, do a DFS. Cool. We're going to do that. We're going to do that. Okay. So yeah, let's start. I guess remove. What is it called? Remove islands. Move islands. Okay. So private void mark visited and matrix int row int column. Um, Maybe I can do a DFS in this part because anyways I can probably do a yeah I can do a DFS in this part because otherwise why I want to do a DFS is by default intrinsically or implicitly it would work with the stack and maintain it and then have the extra space and all of that. But if I am not working with it, I have to create um, I have to create queues for every one of the iteration, for every one of the function call. And if I want to save space in that, which is again a bad thing, so if I want to save space in that, I have to pass in the queue so that I technically don't have to clear it because I would be iterating till the queue is this, but it just inherently or implicitly falls into a more sorry DFS pattern, right? Yeah. So I hope that explanation is good. Let me just adjust my chair. Yeah. Cool. Okay, so you have that. I think we don't need anything else, do we? So instead of giving row listing, I'm just gonna give this and rows and columns. Let's do that. Okay, so private record cell intro column. So one of the things we can have is next cell int uh, direction. So return new cell row plus direction of 0 column plus direction of 1, right? And then cell in range int rows in columns return row. Can you complete it for me? And row less than rows and column greater than columns, and my bad, column less than columns. Yeah. So I created this because it's a boolean. So I created this so it becomes much more easier for us to actually iterate over the matrix. Okay. And in here, I suppose we have to give it the direction. We could have, taken it in this particular, like the class state, but I feel it's not the correct way to go forward when we are working with DSA problems. All right. So if cell in range rows columns, so if the cell is not in range, or matrix dot matrix of cell row cell column not equal to 1, I can simply return Do I have to do something else? I don't think I have to check anything else. So I checked if it's in range, and I checked if it's value one or not, right? So if it's not, we don't care much about that particular thing here, right? So okay, cool. So now what we want to do here is that we want to mark the cell visitor, right? So what we can simply do in here is, yeah, this is wrong, and it's corrections. So matrix of, so int row equal 0, sorry, my bad, cell row, column cell column. Okay, so this thing, मेरा phone है क्या? Huh? Okay, so now in here, um, hmm, in here, I'm gonna simply say that for int direction in directions, okay, cell next cell is cell next cell, the direction, and then I'm gonna call a function. Okay, so let's call the function matrix next cell rows and directions. Yeah, okay, so in here, int directions is, so here I can go left, which is 0 minus 1. I can go right, which is 0 1. I can go up, which is minus 1 0, and then I can go 1 0. There's an issue with my height of the table. I somehow messed it up, which is very, just is giving a weird feeling right now. But okay, we will power through. We will power through. Right. So now, the next thing that we want to work on is first int rows equals matrix length, columns is matrix 0 dot length. Again, right now I'm doing it in this way, but in general, we should be actually doing null checks and things like that before directly calling this. Okay, so here we are doing it because it's again a DSA problem. But if for any actual maybe a coding interview, or more importantly, in my opinion, more than a coding interview, is your um, what is it called? In a production code, it should be like this. Okay, it shouldn't be like, oh, do not do checks and all that. But for this, I guess we're fine. So this is the first row. So you say this is 0, and row is less than rows. Wait, my bad. Mm, So now what you're gonna have to do is mark, sorry, if matrix of row column is 1, you simply mark visited the matrix itself. So the row here would be 0 because that's the first row. And in here, you can say what all things we are passing. So new cell, not cell editor, 0 column, rows, columns, directions. You can also do it for the last row. where you can see rows minus 1. Cool. Now you have to do it for the same rows. Now in here, we'll have to say this is row and 0. First column in here and last column. Well, I have to also change this. Do not forget to change uh, this thing in here. And for the last column, wait a second. Did I do something wrong in here? No, how come this is row? Where did I copy this from? Where it's row? 0 column, rows minus 1. Okay, I don't know why it's this. But yeah. So this has to be, again, it's just row. Oh, because I did the refactor. Okay. So now I'm gonna iterate over everything. Actually, yeah. So for intro is 0, row less than rows, row plus plus, and we do it for columns. Okay, so in here what we say is if matrix of row column is now 2, you make it 1. Else at if this is equal to 1, you make it at 0. You don't have to return anything, I guess. You have to, okay, so it returns a matrix also. Why? Yeah. Anyways, so this I think is basically it. So in here, what you do is as you iterate, you say, oh, if it is 2, which means you have marked them visited in here. So let's do it in here explicitly. So if you have marked it visited in here, you change it back to 1 because you could not have like remove those particular islands. But if it was actually 1 still because you couldn't reach those and it's still 1, it means that you can turn them into water. So that is what I think is going to be the solution. Okay. Yes. Cool. I will be asking ChatGPT to give me the notes. Meanwhile, I'll just take a quick 2 minutes break and I will be back. Okay. Till then, enjoy some good music. Okay, I am back. I am back. Okay. For some reason, the music is not playing. I don't know. I did the setup right and still it got effed up. So, whatever. Again, I'm not going to spend a lot of time there. I'm going to continue working on the problem set. Okay. Cool. I'm going to keep working on the problem set here. Wait, what did I just do? Okay, cool. So, okay, let's keep going. So let's see what ChatGPT generated for us. Is it something stupid? Is it something useful? Uh, don't, yeah, but at least give me proper good 2 3 liner notes for revision. Use DFS from border once to mark land safe after marking convert seller, blah blah blah. Effectively removes islands not touching the border. So yeah, okay, cool. That seems like a good note. Wait a second. If I copy this, where on earth did this come from? ChatGPT said, I don't know. I don't know. Where did this come from? Anyways, close effectively. Okay, cool. So we did 5 problems. Awesome. So we conquered graphs a little bit more. A little bit more, right? So let's move forward. Let's move forward. Let's move forward and come to the part where we are working on the next problem, which is cycle in a graph. Okay. From here, things get a little tough because I know I have not solved these stuff a lot. But let's see. Let's see. We'll try to actually, work on it. And one of the things I had to do was binary k lifting or binary lifting. Let's see if we can do it today. I'm not very sure. Let's go. Okay. I quickly want to see if the song is playing. So I'm gonna go mute for a second. Okay, I guess now you can hear a bit of music. Cool. I hope it's not too loud. I'll just decrease this a little bit. There's mosquitoes and stuff. Okay, cool. Okay, cycling graph. You're given a list of edges representing an unweighted directed graph with at least one node. So the important thing is it's a directed graph. Write a function that returns Boolean representing whether the given graph contains a cycle. For the purpose of the example, a cycle is defined as any number of vertices, including one vertex, that are connected in an enclosed chain. A cycle can also be defined as a chain of at least one vertex, in which one of the vertex is the same as the last. Okay. The given list is what's called an adjacency list, and it represents a graph. The number of vertices in the graph is equal to the number of vertices, the nodes in the graph, is equal to the length of the edges, okay, where each index I contains blah blah in no particular order. Each individual represents a positive integer that indicates a index, okay, a destination in the list that vertex is connected to. Note that these edges are directed, meaning that you can only travel from a particular vertex to a destination, not the other way around. Also note that the graph may contain self loops. A self loop is an edge that has the same destination. Okay. Okay. Refer to the conceptual. Okay. So 1 3 2 3 4 0 empty 2 5. Okay. So let's first understand the question and how it does. Okay, you remove this stuff in here. So this thing here is 0 1 2 3 4 5. So 0, 1, 2, 3, 4, 5, because it clearly says the number of vertices in the graph is equal to the length of the edges. Okay, so there are 6 nodes that you have, or 6 vertices that you have, and then you have edges, which I want to know that. Oh, okay. So from 0 you can go to 1 and 3. So these are destinations because it's an adjacency list, right? So from here you can go to other places. Okay, cool. So from 0 you can go to 1, you can go to 3. What happened? Okay. Yeah, so from 2, 3, and 4. So from 1 you can go to 2, you can go to 3, you can go to 4. From 2 you can go to 0. From 3 you can not go to anywhere, there is no outbound. Then from 4 you can go to 2 and 5. Okay. And then from 5 you cannot go to any place. Okay, cool. So one of the things I can see is if you start from 0, you can go to 1, you can go to 2, and from 2 you can again come back to 0. So that becomes a cycle in here. So that's the first cycle. So it just talks about detect if there is a cycle or not. So it has to be true in this particular case. 0, 1, 2, 0. Yeah, okay. Okay. I'm sorry. Then you also have maybe there are some other. So from 1 if you start you can go to 2, from 2 you can go to 0. Yeah, this is already something that we have noticed. What other things are there? So you can go 0, 1, 2, 0, that is 1. The other thing can be let's start with so you can go to 3 in here, which is not helpful because from 3 there is no outbound. So from 1 you can go to 4, from 4 you can go back to 2, from 2 you can go back to 0. Okay, so this is one more cycle, right? Because you start from 1, 4, 2, 0, 1. Now has to be one more cycle, right? 1, 0, 1. It's the same thing which I did. I just started from 1, so it started from 0. Same thing, right? Start from 0, you go to 1, 4, 2, 1. Yeah. From 2 you go to 0. My bad, sorry. So you start from 0, start from 1 in here. I also went there. So from 1 we went to 4, 2, 0, 1. Yeah, same thing. There should be another cycle that they're talking about, right? This is another cycle. 1, 2, 0, 1. 1, 2, 0, 1. I mean, this is only this is 0, 1. Yeah, okay. So I don't know why it's considering this to be another cycle. But anyways, I feel there are 2 cycles explicitly noticed there. So the important thing here is that it's a directed graph, right? It's a directed graph, which means that we do not have to consider from where we are coming because it is, I feel, implicit in the direction. So what we can do is we can have 0, 1, 2, 3, 4, 5. So we start with 0 and we say, okay, we traveled this, so this is true. Everything else is false in the beginning. So from 0, where all I can go? So I can go to 0 and 3, 1 and 3. So 1 and 3 is in the queue. So I visit 1 and I mark as true. So it is false already. So we are good here. So I come to 1. So from 1, I say that where can we go? So you can go to 2, 3, 4. 2, 3, 4. So you come to 3 again. Okay, come to 3 again. And you say, well, I think, no, this is right. So this is 3 again in here. And from 3, where can you go? From 3, you can go nowhere. So you just won't do anything. Okay. Then you come back to 2. So you visit 2, which is good. But there is 3 again. So this is, but I don't think so. We can say right away that it's false. I don't think so. That is gonna be the solution. Hmm. Just give me 1 second. Sorry. Cool. Okay, so this solution is definitely not working, so we have to definitely come up with something which works. I don't think so this solution is gonna work. No. So I feel what we have to do is we can do a DFS from this node. And we can say from 0 we go to 1, from 1 we go to 2, from 2 we go back to 0. So within a DFS cycle, if something is revisited, that is the only time we can say, okay, so we have to do a DFS. And in the DFS itself, we're going to keep track of what we have visited, what we haven't, right? So I'm going to iterate over every one of the nodes and I'm going to see if I visited that node or not. So if not, so let's say that this 2 to 0 was not there. So it would have gone from 2 to nowhere, right? So you would have just stopped right here. So then I would go to 1. And the problem here is from 1, I have not explored 3 and 4, but it would have automatically explored 3 and 4 because then I would have gone back. And, once I go back in the recursion up, it would have gone to 3 first, nothing there, then it would have gone to 4, and then come back to 2. And that right there would have been the cycle. But let's say this was also not there. So in that way, I can keep use of a single visited set, and I can say that, okay, if I visited or not, if I have not visited a node, I can start an iteration and a traversal from that particular node and explore all possible paths. And if any one of them comes back to an already visited node, I think we can call it a day. Is it that so? Only problem I have here is what if like you already have what if you already have sorry, I'm just getting a text. Just give me 1 second. Okay, cool. So it basically, what if I already visited a node in the beginning? So it's not just about if I visited something. The question here is if I visited the node in that particular DFS cycle. I feel that is what is important. Or I can just reuse the array. This is the only question I have in my mind right now. So if I start from 0, I go to 1, I go to 2, I go down, and so from 2 I go back to 0. So I can immediately say that, okay, I started in this particular cycle, I started from 0, but let's say that 0 was not there. So from 2 everything is done. So you just go back up again, and from 1 you would have gone to 3. Sorry, you would have gone to 3. So if you have gone to 3 and here you see 3 in here, it cannot go anywhere. You just go back up again and go back to 4. From 4 you can come to 2. Now this right here becomes a cycle, right? Because from 1 you go to 2. No, you cannot, because from 2 you have to go back here again. I do not want to go to every node and start an iteration, to be honest. Only thing I'm missing here is just a very small thing where I can capture exactly where my loop is. Okay. One of the easiest solution I think is you go over every one of them and start a DFS. But I feel that is not quite efficient because if I started from 0, 0, 1, 2, 4, I went everywhere, 3. When I come down to 1 again, I would again visit 2, 3, and 4, but I already know for an answer. So can I not use that? Can I not use that information? What if I use a matrix? So I have a 6 cross 6 matrix. 1, 2, 3. And what I do is, when I go from 0 to 1, I mark this as true. So as a matter of fact, I would know whether I travel from 0 to 1 or whether I travel from this thing. Because in here, when I go from 1 to 4 and 4 to 2, I would easily know that if I can travel back to 2 to 1, I cannot travel back to 2 to 1. And it doesn't really matter if I visited 2 or not. I cannot travel back to 2 to 1, which means that I am good in here. Yeah, I think that is what the solution is like. I think that is what the solution is going to be. Okay. So what you can do in here is that you can, I feel, yeah, that's basically it, right? Because here I'm not just keeping a track of my destination. It's basically not just magnitude or something like that. It's also like a, man, what is it called, vector? Yeah. So it has a direction along with the magnitude, right? So that is what we are looking for. Okay. I keep getting text here and there. Keep getting a text here and there. Okay, anyways. So let's see if that actually works. Cycle and graph, okay. I just have a feeling it's not gonna work. I don't know why. Cycle in graph. I just have a feeling that it's not gonna work. Let's see. So private boolean DFS int edges int vertex. Do we have to say anything else? Visited. Right. Let's actually look at the space-time complex. So it's V plus C, which means it's basically NV of space. So it's basically a DFS that we are looking at. And we are also looking at the possibility of where, yeah, I think I want to see the hints a little bit. Just stupid. When traversing the graph, a back edge is an edge from a node to which its ancestor in the depth is, and a back edge denotes the presence of a cycle. How can you determine if the graph has any back edges? To find back edges, you need to keep a track of which nodes you have already visited and which nodes are ancestors of the current node in the previous step. There are a few ways to do this. One approach is to recursively traverse the graph and to keep track of which nodes have been visited in general and which nodes have been visited in the correct recursion stack. Exactly what I'm talking about. You can do that with two separate data structures. If you reach a node that has an edge to a node that's already in the recursion stack, that means you have, yeah, exactly. You can also detect the edge by performing a 3-color depth first search. Each node is colored white to start. Recursively traverse through the graph, coloring the current node gray and then calling recursive traversal function on all of its neighbors. After traversing all the neighbors, color the current node black to signify that it's done. If you ever find an edge to a node that's gray, you have found a package and there's a cycle in the graph. More interested in this part here. So you have a 3-color depth first search. 3-color DFS. Okay, this color indicates that the node has not been visited or preceded. So white is that initially. Okay. So this color signifies that a node has been visited and is currently in the recursion stack of the DFS. Okay, so you're using just a marker on the node itself. Cool. Descendants are being explored, but the processing of the node itself is not yet complete. This color indicates that a node and all its reachable descendants have been fully processed and explored. Okay. The core principle for cyclical detection lies in the gray node during the DFS traversal. Yeah, that is fine. The question here is, how do I even figure out if this thing is there or not? Why BFS assigns nodes with 2 colors and DFS assigns? Can a 3-color DFS be used to identify cycles? 3 coloring is NP complete, really? A K coloring problem. So we are a little bit of TTS stream right now. We're going to be TTSing. A K coloring problem for undirected graph is an assignment of the colors to a node of the graph such that no 2 adjacent nodes have the same color, and most K colors are used to complete graph. Given a graph, there are at most 3 colors. Okay. Elegant engineer is also streamed. Well, okay. Okay. So the point here is that gray visiting in progress. So what we have to do is, when we start traversing the graph, we mark it gray. Okay, that is cool. That is cool. So not int visited. Let's just say color. That's all. So 0 is unvisited. 0 is not visited, and then 1 is currently visiting or processing neighbors, and 2 is basically processed all neighbors. That is basically what the color system is going to be. Okay, so what do we do in here, right? So what do we do in here? We can simply say that what can we say? If color of vertex is 1, turn true. Okay, turn true. Now I'm just gonna say color of vertex is equal to 1. So I mark it processing for int edge So neighbor of edges of vertex, trying to visit them. So DFS edges neighbor color, and let's just call it colors. Okay, let's just call it colors. I'm just gonna call it color. Okay. Now, if any one of them comes back as true, it simply can break out of it and return. If nothing, color vertex is true. 2. Mark it processed and return false. Okay. So in here, what you're gonna do is for int nodes or vertices is edges dot length, and colors is int vertices itself. So in here, yeah, my bad, a little bit tired right now. So then what you simply do is on int vertex vertex less than vertices vertex plus plus. I'm just gonna say a DFS on the edges, the vertex, and the color. If color of vertex is still 0, we said we're gonna do this, yeah. So if this is true, we return true, we break out of the loop, return false. So I guess that is what is, yeah, I guess that is what is the 3-color detection in here. So what we are doing is basically, because the entire thing that I was talking about is actually exactly the same, but it's a very subtle way of managing stuff. Okay, awesome. Because in here we said that we need 2 things, because we were trying to do two of the things, right? Because in the recursion itself, we want to see if we came back or not. And we were trying to use 2 different data structures to do it. Sorry. But the easiest way right now is, which is a very elegant way, is you just use a single this thing. So you use 3 different kinds of flags. You say 0 is not visited. One is I'm currently processing the entire path that I can go through down the chain from a single node, and that once processed, you do a post traversal thing and you say, okay, it's processed now. You can mark them, because once it gets out of here means that everything is processed. So you mark everything processed for that particular node itself and the neighbors, and yeah, that is what it is. So I want a good node for this. Generate a good node for this. Yeah, I hope that was a good one and the explanation is better. Yeah, and it's a good learning. So I learned something new. That is awesome. That is awesome. Detect cycle with 3-color markings. 0 unvisited, 1 visiting. If you visit a mark currently in the stack, a cycle exists. Efficiently way to catch. I want it to be more verbose. So let's be a little bit more verbose so that I can say, okay, yeah. So let's mix this. Okay. So here we can say 0 is this is this, visiting, and processing neighbors fully processed. And in here, if during the DFS we ever reach node with state 1, means we found this thing. This method uses every word and cycles detecting prior. Yeah. Okay, cool. Learn something awesome, which is 3-color. Okay, that is pretty cool. That is pretty cool. We at least came up with the solution ourselves after we got the hints. But it's a very good learning. Cool. We did 2 problems today. Till now. We can go about a little bit more. Wait, did I not submit this guy? I don't think so. I submitted this guy. There's a lot of mosquitoes for some reason. Cool. Cool. Let's actually go ahead and see this in here. Let's go for the second one. Let's go for sync in here now. Okay, I guess I didn't submit it because I just did a run. Minimum passes of matrices. Okay. So write a function that takes in. So I got to take in a couple of notes in here. And what is untitled? Okay, so these are descriptions and all of that. So I guess here 3-color DFS algorithm. I think we should also learn about how to do a cycle detection when it is like there's a directed graph, but I want to do also for an undirected graph. I should be looking to that. But yeah, okay. So minimum passes of matrices. Write a function that takes in an integer array of potentially unequal height and return the minimum number of passes to convert all required integers in the matrix to positive integers. A negative integer can only be converted to a positive integer if one or more of its adjacent elements is positive. An adjacent element is an element that is okay. Converting a negative to a positive simply involves multiplying it by -1. Of course, 0 value is either positive, meaning at 0 you cannot convert an adjacent negative to a positive, so you have to just okay. A single pass for the matrix involves converting all the negative integers that can be converted at a particular point in time. For example, you have 0 minus 2 something something. So if you start from 0, you take this and this and this. Sorry. After a first pass, only 2, 5, 2 can be changed. Okay. And the second pass, okay. I get it. Note that the input matrix will contain at least one element. If the negative numbers in the input matrix cannot be converted to positive, regardless of how many passes are run, your function should return -1. Okay. So this is more like a rotten oranges, right? Because sorry for the sound. Hope that's not distracting or too loud. But yeah, okay. So Okay, cool. Let's look at this part. So how many minimum passes you have to do? So I feel this is more like a rotten oranges thing. Okay, so let's take this example in here. So if you take this example, let's zoom it in huge right on your face. Okay, right on your face. So we take only the positive numbers. Okay, so we take this, we take this, and that's all. So from here on the first pass, you can take this guy, you can take this guy, that's all. So let's just mark this as positive now, and this as positive now. Let's actually, do it like this. 3. Yeah. Okay. So from here, you would have done this guy. You have converted this guy. This guy would have converted this. This doesn't matter. This doesn't matter because you want to go to 0. Sorry, you don't want to go to 0. So this is first pass. In the second pass, you would want to take this and convert this guy and this guy. The others doesn't matter. This guy, this doesn't matter. This is already positive from this one, and so on and so forth. Okay, so that is fine. From this one, this also can become, and this also can become. So it's 1 more. And then in the last round, this guy can become this. So, my precious PC. So from here, you have the third pass. So I guess the answer has to be 3. Answer has to be 3. Yeah. So I think that is what it is. That is what it is, right? And how we can go about this part is that la 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 la. Oh, I can look at analytics here. Wow. I didn't know that. Can I expand this? I just wish, it was not like a widget, and yeah, if I do a pop out, it's a very weird stuff, which I don't like. So yeah, I just wish that there was a single screen with just this, nothing else. But okay, that's fine, I guess. Sorry, that's fine, I guess. So let's actually go back to the original view because I prefer that. Okay, again, I could use a second monitor, but I don't prefer working with 2 monitors. It's just very distracting. I don't prefer working with a huge monitor. I don't prefer working with 2 monitors. It's just me. So I've been thinking of actually converting an old iPad that I have into just an external display stuff. I have been checking on that, and I have seen some of the options that you can do, but apparently Apple is a giant pain in the ass, though I have all the Apple products. Yeah, I mean, I was also young, right? Silly. Okay. Okay, cool. So let's do that. We have to wing it through a little bit while we do this, but we can. So minimum passes of, let us solve it before. I really don't know. Minimum passes of matrices. I wish I could copy. Okay, I can copy it from here, I guess. Okay. Okay, I really want to listen to something else, but I don't know if it's gonna come with some copyright stuff. I honestly have no idea, which I don't want to do, because specifically with T-Series, I have no idea if there are T-Series or stuff like that, but if it is, they can pretty much put a strike for no reason, right? And I don't want that. NCS lo-fi. Is there only one? Okay, so there's something called NCS lo-fi. Okay. For Twitch stream lo-fi music. Okay, let's actually explore this and see how it is. Where's my... So I guess let's swing it. I already hate the music. Sorry, but I'm probably gonna go back to this. Scroll for previous or traffic. Anyways, I don't want this. Can I not remove this? Oh. The artist is called Old Loft. Oh, 3,000 monthly listeners. Wow, nice. Yeah, I feel this is a better music. Okay, cool. Okay, let's go it up. Let's go it up. So here is the code, and okay. So what do we do? Like I mentioned in here, we can simply iterate over these guys and capture the cells which are positive. So int rows equal matrix dot length, columns equals matrix dot length. In here, again, the point here is that I don't want to mutate the incoming input array. So one of the things we can simply do is have another matrix to figure out if we actually visited that area or not, right? Okay. So one of the things, I'm just gonna switch on the So let's do this, right? This is this, and then what you have to do here is that, so you have intros matrix length. Okay, cool. Let's actually not waste time and start. Got a little bit distracted because it's already 91 minutes, so I got a little bit distracted. But okay, we'll wing it. We'll at least try to do two more problems. Yeah. So rows matrix length, column matrix, column length. Okay, so what do we do in here? So we have to first create a cell as usual, int row, int column, cell, next cell, int direction, return new cell, row plus correction 0, and then column plus correction of 1. Okay, and boolean in range cell. Why do we need that? In rows, in columns, this dot return row is greater than equal to 0 and row is less than rows. बाहर का light जला दो क्या? And column is greater than equal to 0. Column is less than columns. Okay, cool. So in deck, you can have a cell on the queue. This new array deck. Int visited. So let's just do a boolean equals new boolean rows and columns. Int passes is 0. Int negative count is 0. For int row is 0, row less than rows, row plus plus, and column is 0, column, columns, column. Okay, so if matrix of row column is greater than 0, I'm gonna have to q dot not append offer new cell row column. Cool. Else if matrix of row column is less than 0, so negative count plus plus. In here, I'm also thinking we should be marking them. Yeah, we should be marking these as visited. So visited row column was true, so that we don't visit them again. Yeah. Okay. So while queue is not empty, the cat is making some weird noises. Okay. So do I look a bit tired? I feel I look a bit tired. But okay. Maybe I can switch on the light a little bit. Look better. I'm not quite sure. My skin may be a little bit missing in here. Anyways, who cares? Let's move on. So you hold, you get the cell in here. Get the cell in here. We have already marked it visited, so we also need directions. So maybe we can go to remove islands and copy over the directions from there. Copy over the directions from here. For int direction in directions, you can simply say cell next cell is cell dot next. You pass the direction. So next cell in range. So first of all, it has to be in range, and visited next cell dot row next cell dot column is not visited, and matrix of next cell dot row, next cell dot column is less than 0. If all of this is true, this is when we start doing some stuff. This is when we say q offer next cell, and then in visited we say Hmm. Next cell row, next cell column is equals to, mark them. But here's a problem. I need to also know, like, at what time a boundary of the day changes, right? I need to know the passes. So min passes. Okay, so let's do one thing. Let's say here in pass. So what is the number of the pass that you're doing at this point? This is this. Okay, so whenever you're creating a new cell, you want to do pass +1 in here. So you always pass along with that. Okay, and min passes, mat max, min passes, and cell pass. So why is it max even though we are trying to find out min? Because from a perspective of the algorithm, it's a minimum, but when we're trying to find it out, it would be the maximum number that we actually can go through, right? The maximum number that we can go through, right? So in here, this would be this. And specifically speaking, when we do this part, also what we have to do is negative count minus minus. So return negative count is 0. You return min passes, otherwise you return this. This is what the code should be, and hopefully this is what actually works. Awesome, it works. So let's go to tests and run a test. Awesome, it failed. Okay, awesome, it failed. Why did it fail? So let's look at this. So this okay, so this cannot, do anything to zeros. This cannot do anything to zeros. This cannot do anything. So these all are bullshit. But in here, this can only affect this in the first day. In the second pass, this can affect this. This is first, second, third, fourth, fifth, sixth, seventh. Why are we looking at? Wait, my code output is 5. The expected output is 7. So wait a second. Wait a second. I did something wrong in here. I think I know why. Else, I probably just have to do this. Because it's a 0. I'm going to mark all the zeros true so that I don't mark them. I just feel this is what I have to do. Let's test my hypothesis. Yeah, that didn't work. Maybe it's something in here. Pass +1, whatever pass it was, you go for the next one. So what else is wrong in here? So row is 0, row column. So if it's a positive one, you queue it and you say pass is 0 because you don't have to do any pass for that. Then you have visited row column equals true, you mark them true. And if it's a negative, you do not mark them visited as of now, but you only increment a count. And if it's 0, you also mark them true because you do not want to visit them anymore, right? So that is what That is what it is. Okay. The next thing you do here is that you try and go and say, okay, let's empty out the queue. So here we have the cell, and we are saying minimum passes is whatever is the max. So at the very first step, it would still be 0. Then you say direction over directions, get the next cell. If the cell is in range, if it is not visited, which means it has to be a negative number, and it's still a negative number. And then you say that here I don't think so you have to do that, because we're already tracking if it's positive or negative with that particular thing. So maybe but I mean, it's just an extra check where you say, okay, it's still negative. This is where you offer it. I mean, you push it into the queue, and then you say visited next cell row equals true. So you mark that particular cell visited, and you also decrement the negative count because this was a negative value for sure. I'm not quite sure what is the issue here. Sorry. If the negative count is 0, whatever minimum passes you've got, you do that. Otherwise, you return 0. Okay. So I think the time has come for some debug logs in here. So maybe system out println q. Will that help? Let's see if that helps. So we have to look for the output in case 3. So everything was 0 in here. So let's do one second. I feel this here is going to be more helpful. So if I just go to quick test and I replace this, and then if I run the code, this I feel is a more useful stuff than going over the entire thing in here. So if I go to the raw output, okay, so you have cell 0, 0. So 0, 0. Then you have 3 something something and all of these things, and these are useless. Okay, so then you pop that out and you push in 1, 0. Okay, so just for the sake of it, let's also do this thing where you also say int value. So if you give int value, I cannot really take that thing into account, so that's a problem. That's fine for now. Okay, that's fine for now. What we're going to do here is okay, let's continue. So you pop out this particular cell and nothing comes in. You pop out this particular cell, nothing comes in. So at some point you would just have 1, 0. Where is this thing? Yeah, so you just have 1, 0. Cool. So from there you have 1, 1. Cool. From there you have 1, 2. Then you have 1, 3. Oh, my bad. No, it's corrected. From here, you can populate this guy and this guy. So it's 0, 3, but you never populated this one. Why is that? You never populated 1, 4. Why? That's the problem. Never actually populated 1, 4, but why is that? So here you simply say row is greater than 0 and row is less than rows. Column is greater than 0, equal to 0. Column is less than columns. Okay, this looks good to me. This looks correct to me. And 0, minus 1, and Yeah, that is not the problem. Okay. Still not sure why. So it's because one of this thing is failing. I wonder if I can just dump this in here. So after I do this, I also want to dump this bit. Okay. Uh, Public static is static. Do I have to do static? No. So void dump. This bit. I think there's something called arrays dot to deep string. I'm not quite sure. If not, we're just gonna roll out our own. Print and then what I do want to do is I want to do this here. After I do that, so let's run this. Okay, so boolean cannot be converted to int. Yes, that is true. You are correct with that. It cannot convert it. So what exactly is it? So if I say arrays dot to string, deep to string. Okay, deep to string. This is false. So everywhere it's false, but here it becomes true for some reason. Okay, I kind of hate that. Because it's boolean. Okay, so also one more thing what I want to do is okay. So the very first time, so your cell is you pass in the next cell, right? Yeah, pass in the next cell. So the cell is this. Okay. Next cell is 1 0. This is still false. This is 3 0. You have nothing in here. So for every one of them, you don't have anything. So when it's 1 1, it's on the past too. Because it was 0 1, your cell is 1 0, so you become 1 1. So this becomes true now. Now your cell becomes 1 1, and your next cell becomes 1 2. So this becomes true. Wait a second. 1, 2, 3, 4, 5. Oh my god. What a dumbass I am. This thing, this thing literally was the bug for the entire time. Literally. And it happens all the time. It happens all the time. Trust me. Okay. Wow. This was a really good one. I feel it's gonna pass every case now. But it's a good learning. I mean, that's how you generally would, debug something and figure out. Here you don't have a debugger, so gotta do that. Okay, something failed, but that's fine. We can still figure it out. Expected -1, your code output 0. Why? Okay, so you have to give -1 and not that. So that is a very small, tiny error, but we finally managed to do it. I feel. Submit the code. Ta-da-ta. Cool. So this is where prompts are. Okay. Time for ChatGPT to give me notes. That was a good one, honestly. Let's see what ChatGPT is generating. Minimum passes, treat positive as BFS sources and convert adjacent this thing. Track the number of passes. So notice this. But I want to very simply say this is same as rotten oranges. Rotten. That's all. And I would know what it is. Okay. Too colorable. So we're going for the fourth problem. Hey, we did this. Stop. So we're going for the fourth problem now. We're going for the fourth problem. You are, and most likely the last problem that I'll solve today because it's already like 115 minutes. Let's see. You're given a list of edges representing a connected, unweighted, undirected graph with at least one node. Write a function that returns a boolean whether the graph is two colorable. A graph is called bipartite. Bipartite if all the nodes can be assigned one of the two colors such that no two nodes of the same color are connected by an edge. Okay. The given list is what's called an adjacency lift and all of that. The number of is equal to, okay, the number of vertices in the graph is equal to the edges, where each index I in edges contains vertex I siblings in no particular order. Each individual edge is represented by a positive integer that denotes an index in the list that is connected to. The graph is undirected, meaning that if a vertex appears at the edge, then the inverse will also be true. Also note that this graph may contain self loops. A self loop is an edge that has its own, so any self loop should make a graph non-two colorable. Okay. So 1 and 2. So 1 and 2 is connected. So 0 is connected to 1 and 2. Then 1 is connected to 0 because it has to 0, and 0 is connected 2 is connected to 0 and 1. Okay. So since it's two colorable, I feel that we can start with any color. But I'm not quite sure if that's not quite sure if that's correct. I'm not quite sure if that is correct. Just give me a second here. Just give me a second. I'll be back. I'm just quickly checking something. Why do you send me videos? Anyways, okay, cool. Cool. So let's take this example, 1 and 0. So I'm guessing it has to be a specific algorithm which is like bipartite. So I just want to see how you pronounce it.
Bipartite. Bipartite.
Bipartite.
Bipartite. Bipartite.
Okay, so it's basically bipartite. Okay. So you have two nodes here, and one of them is of course 0, the other one is 1, and this is connected like this is connected like this. So I can give any color to this. So let's say I give the color 0, and the neighbor I can give another color which is 1. So what I feel here is that we need two things. One, if it is already colored, if it is we can also do a 3-color algorithm here, I feel, because one of them we can say it is not colored, and if it's not colored we pick up into the DFS and we start iterating, and once we start iterating we can say okay, let's give it a color first. So let's give it a color of 0, like 1, because we started with 0, so let's give it a color of 1. The next node that you visit, you're gonna revert it back. Okay. So once you revert it back, you are basically going to say that okay, if something is 2, you, like whatever nodes you're visiting, you already mark them as 1. If anything is not 0 and you came back to that, and if it's like not expected what you're trying to do, I feel that is when you have to say okay, you cannot do it. This is how I feel the algorithm would be going. This is how I feel the algorithm would be going. Can I put in tags and that's gonna help? Not quite sure if it's expecting me. Yeah. Yeah, so just give me 1 second. It's gonna take a minute here. Okay. Okay, so if you're watching it right now, I'm just gonna quickly go over it. So this is basically the intro stuff that I've done, and everything else is the same. I like the style. Okay. So you can go to BRB, it's basically the same style, so it keeps consistency. And outro is this. Oh my god, I did not I did not make it correct. Okay, so now I guess it's correct. But yeah, this is basically it. I think the colors are good, so I'm gonna stick for it now. What do you say? Yeah, so I guess my mic is off when I go to some other like scenes. But yeah, basically I just kept the design consistent across for all three of them. And yeah, I guess you can only hear my mic when it's outro. But yeah, that's what it is. Anyways, you tell me how is it. I feel it's working for now, but you tell me. Cool. Meanwhile, you tell me. I am going to go back to. Cool. Cool. Okay. So let's continue working on this by part. Man, I again forget how to pronounce by part. How to pronounce it?
Bipartite.
Bipartite. Okay. So we're gonna go back to that. Okay, cool. So two colorable. So my idea of this is that I'm gonna visit a node and I'm gonna say, okay, let's start with. Only thing here is that, only thing here is that I wish I could have done something else other than, because if I always XOR with one, it's gonna toggle back and forth. So the starting, I have to keep something else. I cannot keep 0. Otherwise, it's gonna be very easy to toggle stuff, right? It's gonna be pretty easy to. Thanks. So yeah, so it's gonna be easy to toggle stuff. Okay. Cool. So how else can we toggle? How else can we toggle? If you XOR with 0, it's gonna be the same thing. Doesn't make sense. We can create a repository. Okay. I'm just gonna go with zeros and ones. Okay. I'm just gonna go with zeros and ones for now. Later on, I can think. So, what is it called? To color bipartite. Okay. Int nodes. I'm just gonna use vertices. Is basically I'm just gonna call it nodes. Edges select. Okay. And private boolean mark. Or let's say visit. And you have int edges int current node, or let's just call it node for now. Int previous color, int from. So let's call it current node. This is from node, and then this can simply be colors. It can simply be color, right? It can simply be color. Okay. So in here, what we want to do here is that we want to say um, hmm, hmm, if color of current node is equal to color of from node, we have to return false. Okay, we have to return false. Mark node processing. So color current node has to, damn it, we also have to know whatever color it's coming from, right? We also have to know I do promote this, what you're talking about. If you're still on stream, yeah. So this here, I'm just gonna say from color. Well, um, yeah, my brother is texting me right now. I'll just respond to him a little bit later because I'm just losing my chain of thoughts. I'm just gonna make you a mod, buddy. Mm, you stand as moderator, buddy. Okay. What I'm gonna say is, I don't know if you're still there. Anyways, let's go back. So the only thing I'm not comfortable with is, yeah, let's do this. So color of, the from node, and you toggle it, and you toggle it. Okay. So in here, if they are not same, it can also be different. Wait. So I come to a certain node, but it's already colored. So do I care? I don't care, right? I probably don't care. Or color of current node not equals -1, you return this. Okay. But how do you do the first stuff? How do you do the first stuff? Looks interesting. How's it going? How's it going with you? I don't know why. I just feel that it's kind of becoming more complicated than I thought it would be. So if it is equal to whatever node you're coming from, or if it's not equal to -1, it means you already visited the node before. So it has to be like, why are you coming back to that node? You can come back to that node because you have a cycle, but it really doesn't matter if you have a cycle. It really doesn't matter if you have a cycle. So in here, what does it say? In other words, nice that connects the words to itself and self loop. Okay. Or the current node is equal to from node. So this is a self loop, or it's already colored and it's colored the same. So now you cannot do anything about it. So now you color it whatever thing. So in here, let's just do that. If from node not equal to -1, just color this node. Okay. Now what you do? For int edge over edges of the current node, you're iterating over that, and you're saying visit edges, the edge, and this becomes current, and color becomes this. True. I think I'm just messing up something. Let's just see. Visit edges. So for int node is 0, node less than nodes, node plus plus. If colors equals new int nodes, and in here, good. We came from office at 11 o'clock. Wow. You had dinner. Okay, so here, if we say this thing, mark node processing, I just feel that this is not gonna work. If it is equal to 0, that is when we are gonna do this thing. So we're gonna say, wait. If it's false, we're gonna return false right away. We're gonna break right away, right? So we're gonna say visit edges node -1 color. If you cannot do it, you return false right away, and in here you return true. Condition -1 is always true. That is not correct. I think this is not gonna work. Don't know it is from my end or not. There's a network delay. There's always a network delay. Because there's always 2, 3, 5 seconds delay of network. Like network delay as in the video you're seeing and the voice. Because in generally, if I'm saying this thing right now, you will get this voice after 2, 3 seconds or 5 seconds. Okay, there's always a delay, and I've kept a delay because otherwise the bandwidth goes up pretty high. And yeah, I'm streaming at 2K, so 2K should be better. If you just go here and go to 2K quality or 1080p also, I guess 2K can also be better. But yeah, but you had your dinner, kya? Okay. So time for truth. I'm just gonna be wrapping around here. I'm pretty sure this is not gonna work. Okay, array index out of bounds exception minus. Guess we have to check before, because yes, I missed the part that I'm already doing a from node stuff in here. But I think it's not the right way of doing things. Yeah, it still fails, and that's not the right way of doing things. I still have to give it a little bit thinking about how I can progress with this problem. And yeah, since I've been already streaming for not done yet. Already 12 baje. But yeah, even I haven't done dinner, so that's why I think I'm wrapping it up right now. Okay. But in general, how is the voice quality, the video, And the music that I'm playing, is it like you can hear it better? Is it too loud? Yeah. But meanwhile, I guess I'm gonna create a repository. Git gig. So let's do this. Okay, there are gonna be a lot of files in which I have idea, build, and stuff like that. I'm pretty sure. Okay, so so in here, I also wanna do idea. So lead code. What code I have here? Okay, so do I have git ignore in here? Okay, so in here also I have idea, and in here if I go to lead code, git ignore, I'm gonna have idea. Hopefully now this thing doesn't come up. Okay, it doesn't come up. The idea stuff doesn't come up, and anything else doesn't also come up. So I guess we should be good here. So I'm gonna say git all, git commit init. Okay, so I'm just gonna initialize repo, git remote at origin, git at the rate github.com, create day slash DSA prep dot git. Okay, so let's actually create a new repository. Let's call it DSA prep. Okay, create the repo. I guess quickly I want to copy over image upload license in here, and I'm just gonna readme. What's in our readme? Okay. Add readme license. Well, I first need to check if the license is correct or not, right? So 2025, blah blah blah. Yeah. Add readme license. Git push origin. Hit. Okay, cool. So now, what I do want to do is, no, you're not getting my messages on time. Because I have slowed down the messages. That's why. I've slowed down the messages, that's why. And yeah, maybe there's a network delay. So I do not stream on ultra low latency. Also, I'm streaming 2K with 60 FPS. People don't generally do that. People generally would do it like 20 or 30 FPS, I think. FPS for 2K stream. Yeah, you should do it at 30 FPS. So you recommended bitrate is around 8 thing. So I haven't yet explored much on this part, but yeah, I'm doing a 60 FPS on 18 this thing here. You can see 18 kbps, 18,000 kbps, so 18 mbps, right? So it's a little bit on the range, a little bit higher on the range of this thing. But that is what I see that people suggest. But yeah, I have to still explore a little bit. Music is okay. Lo-fi voice is pretty clear. Okay, awesome. Yeah, that's basically it. Cool. So this being it, I think here is the code, and let me just see if it actually did a push. Okay, cool. I'm gonna fix this up later on about that. For now, I'm just gonna give you some in the chat. If you feel it's useful to anybody, GitHub link is this. yeah, so if you feel it's useful to anybody, do give it a star. Go ahead and give it a star. I'm definitely not going to accept any pull request here because this is my learning platform. So definitely cannot be any pull request, or it cannot be an actual open source project. This is more of learning for me. So, but yeah, whatever learning I'm going to have, I'm going to document it more on the streams. Maybe I can cut down to short videos if you want to learn something. But yeah, I still haven't given a thought about that. Okay. So this has been the day 2 of just exploring a little bit on the graphs. It has been pretty good. So bipartite. So I got to learn what a bipartite, like how to do this algorithm. I got to learn that. Um, Binary key lifting is something which I still didn't actually get time to learn. But let's see if I get time. And this was pretty new, whereas like 3-color DFS algorithm, which is a very interesting algorithm in my opinion. So you have like 3 colors, and because previously I was thinking of having 2 or 3 different data structures to figure out that which particular which particular nodes I'm currently visiting, which particular nodes I'm currently like in the recursion, which particular nodes I have not visited, and all of that. So 3-color DFS algorithm is a good learning for me, and it's a great idea. You just take a single color and say, okay, if it is this particular color, it means it's not processed. Then you have an intermediary section which says that, okay, intermediate color, which says that, okay, you are in this zone where you're still in the recursion, so you're just processing itself and its neighbors, you're not completed, so you still go ahead with that. And then the final color is saying, okay, you're doing this thing. So one of the things which came in handy was cycle and graph. So here one of the things which came in handy was that, okay, so you market processing, but here you do a post traversal mark again. So a lot of people ask why post traversal is required and things like that. So this right here, after you do the recursion, you do that. I don't know how you can convert it into a tail recursion function. This is not, because it has a return statement here, it has a return statement here. I don't think so the optimizer can actually optimize it for tail recursion, if I'm not wrong. Okay, but yeah, so this one I couldn't do, too colorable. And anyways, I'm pretty low on energy also. I've been talking for almost 2 hours now, and after an entire day of office, talking for 2 hours straight up is pretty hectic. But yeah, I'm gonna think about it a little bit. I'm still not gonna look into the hints or solutions or anything like that. I'm still gonna look into the different kinds of, like, think about the different possible solutions. And tomorrow maybe I come live, maybe I don't. I'm not quite sure. 27th we have Ganesh Chaturthi, so if you're watching from India, you are already aware of it. And yeah, it's a nice festival. So 27th and 28th, I'm probably gonna be off, most likely. 28th night, I might come back because it's on the second day. But yeah, let's see tomorrow if I get time, because I have lots of work at home for the puja. So let's see. Meanwhile, thank you so much, everybody who joined in. Thank you so much, and it was a great pleasure to have a good session. It was a great pleasure. I learned quite a bit, and thank you so much for joining. If you like this kind of content, do sorry, do consider giving it a thumbs up. Do consider subscribing if you want to, go more into details of how I do stream. And yeah, we can connect over LinkedIn. We can connect over Discord. I've created a Discord server which is not active right now, so I don't use it that often. I don't use Discord that often, but yeah. There's also createday.com, which you can visit and see my social handles, so we can connect there if needed. I'm happy to help out anyone if anybody has questions about anything. And yeah, thank you so much for everybody who tuned in. Thank you. It was a good stream, and good night. Thank you. Bye-bye.